Good morning and welcome to the third session of the CBSE class 11th economics. And
Hello, sir.
today we're going to continue with Unit 2 of Statistics for Economics.
Okay.
So, yesterday we completed all types of sampling methods such as questionnaire, pilot survey.
Yeah,
Yeah, so we'll continue with the frequency distribution because we have completed census and the population surveys as well. So this is the text of the second unit of the Statistics for Economics. The chapter name is Collection of Data.
yes,
And Census of India and NSSO have also been covered in the previous session.
yes.
Okay. So should we solve the exercises?
Yes, sir.
Okay. So, in the first question of the exercises, frame at least four appropriate multiple choice options for following questions. So the first question is, which of the following is the most important when you buy a new dress?
So we're supposed to make the MCQs, right?
Yes.
Okay. So, uh, price,
Okay.
the material,
Yes.
quality,
Yes.
the color.
Sure. So they can be the four multiple choice questions, and it can also be the raw material used as well.
Okay.
And the second question is, how often do you use computers? Regularly,
And
frequently,
yeah, regularly, frequently,
weekly?
often. Yes.
Okay. Weekly or monthly?
Yes.
Okay. So which of the newspapers do you read regularly? The Hindu, the Times of
Um,
India,
Times of
or the
India,
Business Line, Economic
Time
Times?
Globe Mirror,
Okay.
Hindustan Times, the
And the rise in the price of petrol is justified.
yes, and
So what can be the four options to be given? Price or inflation,
yeah,
oil prices go up,
yes,
crude oil prices reach a higher price. That's why there's a rise in price of petrol.
yeah,
And it can also be that the petrol is in high demand.
not enough supply because
Yes.
it's yeah, okay,
So this has been sent. This can be solved as an assignment.
yeah. I just saw it like while
Okay.
opening the email. I will do it by tomorrow.
Sure, sure. There can
Thank
be
you,
more
sir.
time taken. If any doubts, we can solve it in class. So we'll just
Okay,
continue with the PowerPoint presentation of frequency distribution.
okay,
So yesterday we have finished sources of data, and we have also covered the census and the National Sample Survey Organization. We started with organization of data, and now we are coming to frequency distribution. Yes. So in our day-to-day life, recording information is very crucial. A piece of information or representation of facts or ideas which can be further processed is known as data. The weather forecast, maintenance of records, dates, time, and everything is related to data collection. The collection, presentation, analysis, organization, and interpretation of observations or data is known as statistics. We can make predictions about the nature of data based on the previous data using statistics. Statistics are helpful when a large amount of data is to be studied and observed. The collected statistical data can be represented by various methods such as tables, bar graphs, pie charts, histograms, or frequency polygons. So, bar graphs look something like this.
yeah. There's a yeah.
Is this also a time series graph?
What?
Is this a bar graph?
Yeah,
Okay, and
used to be more, but yeah,
yes, there's still
yeah,
There'll be usually 3 to 4 bar graphs, and we plot on the x-axis and on the y-axis. There'll be different variables on x and y-axis. And pie chart, something looks like this. There'll be
Yeah.
percentages assigned in pie charts.
Yeah.
So what all can we measure on the pie chart? Can we measure the question as can be represented by pie charts showing the different percentages?
Like, yeah, yeah.
Yes. So we can assign different percentages to each of the questions answered in the questionnaire.
Put
Can
it in
we
the
give
pie
an
chart.
example to plot something on the pie chart?
Uh,
Can we take fruits, for example?
Yeah, yeah, different types of fruits.
We can take it and mention each fruit in each pie.
Yeah,
We can just plot the expenditure on fruits. So we can just call the bigger pie chart as the most, at least 50% or 45%
yeah,
of the
yeah.
expenditure is on apple, let's say.
Okay.
And we can plot at least 15% on mangoes. The expenditure on mangoes is 15%.
Yeah,
And we can plot the other fruits on these pies.
yeah.
So we can get the total cumulative percentage is 100, right? In a pie.
Yes.
Okay.
Yeah.
And what can be called as frequency polygons or histograms?
Frequency polygon is like you put dots
Okay.
and then you draw a line from the zero,
Yes.
from the like you continuously draw lines.
Yes. 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 Histograms can also be plotted.
Yeah, it's
A
like a
line.
bar diagram, but it's like right next
Yeah.
to each other.
Yes. Okay. So we are familiar with all the types of representation of data like tables, bar graphs, pie charts, histograms, and frequency polygons. In
Yes.
statistics, a frequency distribution table is a comprehensive way of representing the organization of raw data of a quantitative variable. This table shows how various values of a variable are distributed and their corresponding frequencies. However, we can make two frequency distribution tables, which are discrete frequency distribution and continuous frequency distribution. Okay. And the presentation of data on is made on the basics of diagrammatic presentation. There's a concept of diagrammatic presentation as well. We'll define it. It is a technique of presenting numeric data through pictograms, cartograms, bar diagrams, and pie diagrams. It's the most attractive and appealing way to represent statistical data. Diagrams help in visual comparison and have a bird's eye view. Under pictograms, we use pictures to present data. For example, if we have to show the production of cars, we can draw cars. Suppose the production of cars is 40,000. We can show it by a picture having 4 cars, where one car represents 10,000 units.
Okay.
Under cartograms, we make use of maps to show the geographical allocation of certain things. Bar diagrams are rectangular and placed on the same base. Their heights represent the magnitude value of the variable. The width of all the bars and the gaps between the two bars are kept the same. Pie diagrams is a circle that is subdivided or partitioned to show the proportion of various components of the data. Out of the given diagrams, only one dimensional bar diagrams and pie diagrams are there in our scope. So are we clear with this? So we drew bar diagrams and pie diagrams.
Yeah.
And cartograms are represented using maps,
Yeah.
whereas in pictograms we use pictures.
Yes.
So we'll be very familiar with these. We'll head to geometric diagrams. The diagrammatic display of information allows for the most rapid understanding of the actual issue to be explained by data as compared to tabular or textual information presentation methods. The diagrammatic presentation of data effectively translates the highly abstract thoughts contained in numbers into a more concrete and easily understandable form for the audience. There are several different types of diagrams that are commonly used. Basic geometric forms are among the most important types. Examples of geometric forms are indicated below. So we drew a pie chart, which is 360-degree having 100 equal portions.
Yeah.
Okay. So we are very familiar to represent a pie chart or a pie
Yes.
diagram as well. Okay.
Yeah.
Bar diagram is also we displayed it on the whiteboard. There are two types of
Yeah.
data that can be used for this: frequency data and non-frequency data. When dealing with non-frequency data, a particular characteristic such as production, yield, population, or any other characteristic is noted at various points in time or different states, and corresponding bars are drawn with corresponding heights based on the values of the characteristic to construct the diagram. It does not matter whether the characteristics are measured or tallied because the values of the entries keep their individual identities. Okay, so there are types of bar diagram which are simple bar diagram.
Oh, hello.
Yes.
Okay.
And next chapter is, or the next concept in the unit 2 is frequency diagrams. We did represent
Hmm.
in tabular form or diagrammatic representation.
Okay.
So we have studied ogives.
No, I didn't understand what that is.
Okay. We'll go through ogives, most important, which we have missed. So what can be this table called as?
Um, this table,
Okay.
frequency, it says the frequency.
This is just the age, frequency, class width, and frequency given. Okay, this is a frequency table.
Yeah.
That's right. And this there's frequency of 6 in the age group of 10 to 15, whereas in the age group of 16 to 20 there's a frequency of 15, and there's a class width of 5. What is known
That
as a class
means
width?
the number of people, like in this, the number of people that are in between the ages of 16 to 20.
Okay. And what can be called as 21 to 27, the age group? The frequency is 21. How is the class width 7? Yeah.
Because there are 7 people that are
Okay.
in the age group of that.
Yes.
Yeah.
And how can we get the frequency of 21? Is it
It's
already given?
because, yeah, it's given, but it's
Yes.
because there's more people that are at the age of 21.
Okay. A frequency polygon is a plane bounded by straight lines. Usually, four or more lines are used to create a frequency polygon. A frequency polygon can easily be created by joining the midpoints of the top of all bars or consecutive rectangles of the histogram with small straight lines. The two ends are joined using a dotted line at the baseline to derive the area under the curve, representing the data set's total frequency. This method is the most widely used method of presenting group frequency distribution. An alternative to a histogram, frequency polygon can be made with or without constructing a histogram. So we are coming to ogives. Ogives are known as cumulative frequency curves. Since there are two categories of cumulative frequency, less than and more than, ogives for any group frequency data are also drawn in two types. While for the less than ogives, the cumulative frequencies are plotted against the upper limits of the class interval. For more than ogives, they are plotted against the lower limits of class intervals. The shape of less than ogive rises upward, whereas the shape of more than ogive falls downwards. Interestingly, the interaction point of the two ogives gives the median. Can we represent an ogive in the whiteboard?
Um, I
Yeah,
don't know.
yeah, it can be represented here. We'll just be back in another minute. We'll take a break.
Okay.
Yes. So this is a representation of an ogive.
Uh, I don't understand how
Okay,
this
we'll
works.
explain it going forward. Yeah. So
Okay.
There are two methods of ogives here. There's less than ogive. Just name this. Another one is greater than ogive. Have you studied ogives in class 10?
I don't think we did. So,
Okay. Have you solved graphs like this?
no, not ogives.
There are two types of ogive, which is less than ogive and greater than ogive, or greater than or more than ogive.
Okay.
So we just need to know the basic definition of ogive and how to represent it. So the graph given and which is represented diametrically represents the less than and the greater than ogive curves. The rising curve, which is known as the rose curve, represents the less than ogives, and the falling curve represents the greater than ogive. So we can name this as the rising curve is the falling curve represents the greater than ogive, whereas the less than
Okay.
ogive is the rising curve. So are we
Okay.
clear with this?
Yeah.
And what variables can we plot on the x and the y axis?
Um.
Any example? Can we plot marks and frequency?
Yeah. Since yeah.
Okay.
But if you're saying
We,
less than and greater than, that means we need to have something to compare it to.
okay. So this is just two types of ogive which are plotted. Usually in example problems, only one type of ogive will have to be plotted, where they'll
Uh,
be giving the marks and the frequency in the table,
okay.
and we have to get the more than cumulative frequency, or rather, we have to plot the less than ogives for marks and or the greater than ogive.
Will
So
they tell
this,
us which one we have to find?
yes,
Less
they
than or
will.
greater than?
Yes,
Okay.
yes. So for marks and frequency, we'll have to use the greater than ogive or the falling curve. So this is
Okay.
the falling curve. This is the rising curve.
Okay.
So we are clear with this.
Yes.
For now, there are not many problems given. We'll just have to go through the textbook once again. Uh,
Okay.
have you gone through the textbook or have you glimpsed through?
Yeah. A little bit. Yeah.
Is it are the exercise stuffs or are they given
I
questions
didn't
about
look that
ogives in these?
in the textbook exercise. It was just MCQs. Near a bit of
Okay,
the small one markers. I mean two
okay.
markers.
So are there any questions regarding ogives in it?
No.
Not really, yeah.
Yeah.
So we may not have to solve any problems, but we'll have to know the
Yeah.
definition and how to represent it definitely.
Okay.
So we go back to the presentation. So the next concept is the arithmetic line graphs. A graph showing arithmetic values of a variable is called arithmetic line graphs. Often such graphs are constructed to present time series data, that is the data corresponding to different weeks, months, or years. Therefore, arithmetic line graphs are often called time series graphs. A time series graph is a line graph that shows data such as measurements, scales, or frequencies over a given time period. They can be used to show a pattern or trend in the data and are useful for making predictions about the future, such as weather forecasting or financial growth. So, a lot of finance companies and agencies, which is the weather forecasting agency in India? Is it the Met or the Meteorological Agency?
I don't know.
Okay. So there's something called as the IMD or the Indian Meteorological Department, which is the weather forecasting department of India.
Okay. Okay.
So they use time series graphs to forecast weather because usually weather is forecasted for a week prior to the week, right?
Yeah. Yeah.
Yeah. And even financial growth is estimated via time series graphs. So they project revenues in companies or in the government to increase. That is only through the time series graph they get to project or forecast. So to draw a time series graph, we need a set of axes. The horizontal axis always shows the time period and the vertical axis represents the variable being recorded against time. So horizontal or the x-axis shows the time period and the vertical, which is the y-axis, represents the variable being recording against time. For example, the time series graph shows the temperature of a town recorded over 2 years at 3 monthly periods known as quarters. So there are 4 quarters in a year,
Okay.
and over a period of 2 years, there are 8 quarters. The temperature of a town is measured for the period of 8 quarters, and it is represented by
Okay.
a time series graph.
Okay.
So we have come to the end of the unit 2,
Okay.
which we have covered in a very quick manner. We have
Yeah.
covered most of the concepts according to the syllabus from NCRT, and we are also referring to the textbook as well. So, is there anything different or anything left out from the textbook which we have not covered in the PowerPoint presentation?
Um, I don't think so. There is stuff like uh, uh, the bivariate and univariate frequency.
Okay.
That stuff. Frequency array. Something we did.
On which page number?
Oh, around the some page 30.
Okay.
30. In chapter 2 only. I don't know if it's in unit 2 or not.
Before we head to that, you might have heard of exit polls recently.
Yeah, but I'm not sure what it is.
Exit polls are just the elections which happens during election coverage. The TV
Yeah,
channels or the networks, they provide exit polls just after the voting or the election happens. And it is before the results are announced for the election. Exit polls are announced by media channels.
yeah,
They are projected on TV channels from the data which they collect from voters on which political
yeah,
parties they voted for. So they only ask select group of voters which can also be called as a sample. After that, they
Okay.
make the prediction on which party is winning the election based on the vote polled.
Okay.
So, are there always accurate or correct predictions made in exit polls? Not
I
really,
don't
because
think so. Yeah.
the election result will be many times different from the exit polls projected. So recently there
Okay.
was the election of Karnataka
Yeah.
in early May. So the
Yeah.
exit polls were announced just soon after the voting on May 10th. So the result was in 13th, whereas the election exit polls were announced on the May 10th evening itself. So it was
Oh.
quite different from the exit polls to the election results. So it is not always accurate, but there is data collected from a sample of voters based on which the results are predicted.
Hmm. Okay.
And yes, which concept do we have to go to exactly?
Huh?
Have you missed out
Um.
any concept?
um, hmm.
Yes,
I think the loss after page 33, I think we did loss of information.
is it in page number 8?
Page number 33.
Okay. So this is just chapter for the academic year of 2023-24. If there anything left out, and if there's anything which is not covered in the PowerPoint presentation, we can just do a recap. Okay, this is page number 20.
Oh, wait, never mind. I was in a different chapter. So I got
Okay.
confused. Okay.
Are there any things
So,
which are left out in this chapter of Unit 2? We can
no.
just go through the recap. So data
Okay.
is a tool which helps in reaching a sound conclusion on any problem. Primary data is based on first-hand information. Survey can be done by personal interviews, mailing questionnaires, and telephonic interviews. Census covers every individual unit belonging to the population. Sample is a smaller group selected from the population from which the relevant information would be sought. In a random sampling, every individual is given an equal chance of being selected for providing information. Sampling error is due to the difference between the value of the sample estimate and the value of the corresponding population parameter. Non-sampling errors can arise in data acquisition by non-response or by bias in selection. Census of India and National Sample Survey are two important agencies at the national level, which collect, process, and tabulate data on many important economic and social issues. So, can we just elaborate on sampling error?
When the exit polls can't
Yeah,
properly predict that. Yeah.
yes. The population consisting of numerical values has two important characteristics which are of relevance here. Firstly, central tendency, which may be measured by the mean, the median, or the mode. Secondly, there's a dispersion which can be measured by calculating the standard deviation, mean deviation, range, etc. Are we clear with the range? These
Yeah.
are some important terms to be kept for statistics. The
Okay.
standard deviation, mean deviation, range will also be there in undergraduation of economics and in statistics as
Okay.
well. Whereas in statistics, it's of paramount importance. So we should know these
Okay.
terms like range, mean deviation, standard deviation, and sampling.
Okay.
So the
Okay.
purpose of the sample is to get one or more estimate of the population parameters. Sampling error refers to the difference between the sample estimate and the corresponding population parameter. Actual value of the characteristic of the population, for example, average income, etc. Thus, the difference between the actual value of a parameter of the population and its estimate from the sample is the sampling error. It is possible to reduce the magnitude of sampling error by taking a larger sample. Consider a case of incomes of 5 farmers in Manipur. The variable X income of farmers has measurements of 500, 550, 600, 650, and 700. We note that the population average of 500 plus 550 plus 600 plus 650 plus 700 divided by 5, because there are 5 values given. The average value can be determined by dividing it by 5, which is
Yeah.
3000 divided by 5 is equal to 600. Now, suppose we select a sample of 2 individuals where X has measurements of 500 and 600. The sample average is 550. Here, the sampling error of the estimate is equal to 600, which is the true value, minus the 550, or the estimate, is equal to 50. So it is very similar to the exit polls, which we discussed earlier.
Yeah.
So, for example, a political party may get 120 seats if there are less sampling done, whereas the actual sampling shows that there'll be a projection of at least 100 seats. So the difference between the sampling error or the true value and the estimate will be 20 in exit polls. So are we clear with sampling errors?
Yeah.
And there are non-sampling errors which are more serious than sampling errors, because sampling error can be minimized by taking a larger sample. It is difficult to minimize non-sampling error even by taking a large sample. Even a census can obtain non-sampling errors. Some of the non-sampling errors are sampling bias, occurs when the sampling plan is such that some members of the target population could not possibly be included in the sample. Non-response errors occurs if an interviewer is unable to contact a person listed in the sample, or a person from the sample refuses to respond. In this case, sample observation may not be representative. So there are errors in data acquisition as well. This type of error arises from recording of incorrect responses. Suppose teacher asks the students to measure the length of the teacher's table in the classroom. The measurement by the students may differ. The differences may occur due to differences in measuring tape carelessness of the students. So
Okay.
similarly, we want to collect data on prices of oranges. We know that prices vary from shop to shop and market to market. They also vary according to price. We can only consider the average prices. Recording mistakes can take place as the enumerators or respondents may commit errors in recording or transcripting. So we've come to the end of the session. We'll continue it tomorrow.
Okay.
Thank you.
Okay.
We'll join in
Thank you,
at
sir.
11
Okay.
a.m. on 25th. Thanks a lot and
Okay.
have a great
Thank you,
day.
sir. Yes, sir.